Okay, calculus class, first day. Hopefully the recording works out because the first time I've done it this year, I didn't really practice ahead of time. We start with this big idea. It'll take you about 3 days to really fully comprehend this big idea. But the study of calculus, we could have a number of different approaches. We're going to try to start with this. Given a curve with a line tangent at a given point on the curve, find the slope of the tangent line. That's our goal, is to be able to find a slope of the tangent line today. And so if I were to draw a curve and give it a title, we'll say f of x, and I have a point on that curve, really anywhere, and I have a line tangent. What does it mean to be tangent? It touches once. I would be able to like to determine the slope of that line. Suppose that this is the point 1, 4. Okay? You tell me, why is it difficult to try to compute the slope of that line? Because you only have 2 points, you're given 1. I'm sorry, you need 2 points, you're just given 1 of them. So this is difficult because you only know 1 point. So Jonah brought up yesterday, we'll be investigating limits. He is correct. And limits aren't necessarily that difficult, but to understand why we need limits, we investigate this problem. So we look at the function x squared plus 1. What does that look like? It's a parabola shifted up 1 unit, okay? Is the point 1, 2 a point on that function? Is 1, 2 a point on that function? How do you know? Because when you plug in 1, you get 2. Okay, good. We're keeping up. So we got 1 and we've got 2. So if you plug in 1, you get 2. So this is, we're going to call this point P. And we're going to give it a coordinate of 1, 2. Now I'm going to draw a line tangent at that point. Okay, so I'm not doing the problem yet, I'm just setting it up. This is the problem. You would like to be able to look at that line and know what the slope of that line is. Don't know it, do we? So what we're going to do is we're going to create a second point. Because you said, and I agree, that right now we need 2 points. So let's create a second point. We'll create a second point and we will call it point Q. We'll make it have an x value of 2. If it has an x value of 2, what is the y value? 5. How do we get 5? Plug it in. 2 squared is 4 plus 1 is 5. I now have a different type of line. Is this line a tangent line? Tangent lines touch once. A secant line touches twice. So secant and tangent are really your 2 vocabulary words today you need to identify. Would everybody agree that the slope of the secant line is approximately the slope of the tangent line? Is the slope of the secant line would be an overestimate for the slope of the tangent line or an underestimate? It will be an overestimate. Why? It's steeper. Yeah. Let's find the slope of the secant line, and at least we'll know that it's not going to be bigger than that. Agreed? So in order to find slope, I just need 2 points. It says point P has a coordinate of 1, 2. Point Q has a coordinate of 2, and we said 5. How would I use those 2 points in order to determine the slope? Five minus 2 over, and I get 3. So I know that at the very most, it would be 3. It's got to be less than 3. Agreed? Well, I'm not satisfied with an estimation of 3. I'd like a better estimation. What could we do with point Q in order to come up with a better estimation? Move it closer to what? Move Q closer to P. Does that sound like a good idea? So instead of having an x value of 2, let's have an x value of 1.5. Does that sound like a deal? All right, let's try it again. X value of 1.5. Looks like that line is a better approximation, doesn't it? But in order to find that slope, I'm going to need a y value. If my x value is 1.5, how do I find my y value? 1.5 squared is 2.25, plus 1 is 3.25. I can now use my slope formula to determine the slope of that secant line. What I would like you to do is I would like you to continue filling out this chart. We're going to move it closer and closer. We're going to move it to 1.1. We're going to move it to 1.01, so we can get very close to 1. Okay, go ahead and see if you can come up with what you think is a good estimation then for that slope. Go ahead, work on your own, or together with a partner, just not with me. I don't care. I'm going to ask you guys to pause where you're at, but when you compute the slope here, did you get 2.5? And as you notice, we had a coordinate of 1.5. So we want to move it closer because we're still not satisfied with that estimation. So we moved to 1.1. Came up with a slope of 2.1, and then 2.01, and then 2.001. So if you see the problem all the way through, looks like that's it. We're pretty close, right? 1.01, like that's really close. 1.001. It's really close to point P. It's probably a good approximation, isn't it? Anybody want to look at this data and make a guess about exactly what you think the slope is at that one point? 2. And that is the idea of a limit, that we would look at the data and try to make an educated guess as to what it is headed towards. That's a very poor definition of a limit, but that's what we're going to go with right now. Now you're going to take out your calculator, and we're going to do something really cool. We're going to go into y equals, and we're going to actually type in the function, which is x squared plus 1. And as I graph that, you can see that it's a parabola like we drew, but imagine being able to draw a line that's perfectly tangent to it at one spot. Let's check our work to see if we got it. We came up with a slope of 2. Let's now try to write the equation for the tangent line. Can somebody tell me, if I'm going to write an equation, what 2 things do you need? Slope and the point on the line. So we know it goes through just one point. What's that one point? 1, 2. What was the slope? So y minus 2 is equal to 2 times x minus 1. And when you simplify that and put it in slope-intercept form, you sure enough get y is equal to just 2x. So as I go to my calculator and I type in 2x, and you go to the graph, you can see, isn't that beautiful? It touches at just one spot. That's rather impressive to say that you were able to do that. If I would have given you a calculator ahead of time and said, try to come up with an equation for a line that touches that one just once, that could have been a struggle. And we came up with it perfectly. That entirely changes the way that the world works from the year 1600 on. Calculus applied, and the ability to do this changes everything. We're not going to show you the applications for a couple months yet, but the raw mathematics we will show you. Flip it over. We're going to try to get this piece in before lunch, and then we're going to do some problems that you're going to see on your homework assignment. Okay? So here's the big concept idea. It says the solution to the slope of the tangent line problem can be expressed this way. And we're going to use this notation beginning on Tuesday. But this limit piece, this means as Q gets closer to P. Did you see from our drawing that we're trying to draw a Q closer to P? It wasn't very far away, was it? Well, let's think about it, okay? Let's let Q get close to P. What was point P? 1, 2. Was Q always the same, or did it change? It changed, didn't it? So we'll use an x variable because it always changed. When I plug x in, what do you get? You get the function, don't you? You get x squared plus 1. And our goal was to come up with the slope. And the slope is equal to y sub 2. Look at this problem right here. What is y sub 2? X squared plus 1 minus, what's y sub 1? 2 divided by, what's x sub 2? X minus 1. And as you can see, that's what we got. We used this and we put in different values for x. What did we let x be equal to? What was the first number we chose x to be equal to? 2. And then we got closer. Then what? And then so on and so forth, right? What number could we not plug in for x? 1. Why? Because it's not part of the domain of that slope function, right? You would get a 0 in the denominator. So let's use that to be able to do another problem. So this is what you're going to be doing your homework assignment today, are these two types of problems. So you really want to make sure you understand this. Find the equation for the line tangent to this curve at x equals 8. Let's try to get an understanding first of what the curve looks like. What does the square root of x plus 1 look like? Shifted to the left 1 unit, okay? So it starts here and it goes like that. Everybody okay? We're going to try to find the equation for the line tangent at x equals 8. There we have it. So what I'm going to need is I'm going to need a point on that line. This point right here, this point of tangency. What is the x value for that point on that line? It is 8. Can I find the y value? How? Plug it in. Square root of 8 plus 1 is 3. Awesome. That would be point P. I'm going to need another point. I'm going to call it Q. Go get some brain food and come back, and we'll get into that. All right, let's give it a shot here. So you guys did a good job picking these pieces up, but if we if we have Q, Q has an x value of x, what would the y value be? For x plus 1. Yeah, it's just the function. So what we're going to do is we're going to create a slope function. So notice on the front side, you guys had to type in the slope like 5 times to come up with all those results, right? Now what we're going to do is we're going to write a slope function and just use our calculator. It's going to be a lot quicker. So let's write a slope function. The slope is then equal to, what's y sub 2? Good. Minus 3 all over x minus 8. That's our slope function. We're going to take our calculator, we're going to plug that in. And you got to be careful when you plug it in that you use parentheses appropriately. Square root of x plus 1. And then it's minus 3 parentheses divided by parentheses x minus 8. Okay, so you got to make sure you divide by everything in the denominator. Here's where you got to start thinking. If I graph that, will that produce this graph? Does this graph, what is the equation for this graph? Square root of x plus 1, right? Is that the same as this? No. It will not produce that graph. Okay? We're not sketching a graph of the original function. We are creating a slope function. We are going to use a table value in order to determine what our slope is. So let's look at our picture here. This is point P, right? What is an x value that's close to 8? Not right at 8, but close to 8. Sure, 7.9 or 8.1. But I'm going to kind of ease into it. I'm just going to punch in 9. So let's say I have an x value of 9. It tells me that the slope value would be 0.16228. Well, would you like to get closer than 9? What's something closer than 9? So like 8.5, 0.16441. Let's get closer than that. 8.1. Let's get closer than that. 8.01. Get closer than that, 8.001. Now, watch what happens if I actually plug in 8. Why? Because in the denominator, I have x minus 8. So that would be if you're trying to find the slope exactly at one point, which we can't technically do yet. We can look for the trend, yes. You probably have something typed in incorrectly. If you check the y equals, you can check to see what you got again. It's all right. So, as you look at your table values, anybody want to make a guess as to what the slope is? What is it trending towards? Sure, 0.16 repeating, right? Do you know what that is as a fraction? 1/6. If you don't know that that's 1/6, that's okay. You could just write down 0.16 repeating and use the decimal. But it is, in fact, 1/6. I now have enough information to find the equation for the line tangent. I need two things. I need a slope and I need a point on my line. Both of those I have right here, don't I? So I'll say y minus what? 3 is equal to 1/6 times x minus 8. I will multiply through y minus 3 is equal to 1 over 6x minus 8 over 6 is 4 over 3. 3 is like 9 over 3, so if I add that, we get y is equal to 1 over 6x plus 5/3. I want to be confident that I've done this problem correctly. So the best way to check is to take my calculator, get rid of the slope function, and type in the original function, square root of x plus 1. And then we're going to type in the equation for the line tangent, which is 1 over 6x plus 5/3. And you can see as I graph it, I have my radical equation, my square root, and then does it look like that line is tangent? Yeah, pretty cool. So the graph check, I will draw that, just showing that I verified that I do have a line tangent. Again, I want you guys to make sure that you understand that you can check this answer. It's imperative as you move forward in calculus that you understand ways to check your answers. It's not as easy as just plugging a number back in, is it? So you've now seen two examples. Let's try to take ownership as a group, that you guys can walk me through this, and that I don't have to do as much of the explaining. Our equation for the line tangent is going to be tangent of x, and we would like to find the line tangent at an x value of pi over 4. So can somebody tell me How do I get started? What's my point on my line? Pi over 4 is the x value. Now what? Tangent of pi over 4, so my calculator should be in radians. Or maybe you just remember that pi over 4 is how many degrees? 45, and you remember that that makes a 45, 45, 90, because you're really smart. You remember the root of 2 over 2. So you remember that in order to compute this, tangent is going to be y divided by x, so it will be 1. If you didn't know that, you could go ahead and type that into your calculator. But I show you that because 50% of your AP Calculus exam is no calculator. 50% of it is calculator required. So I want to make sure you understand. Okay, so we have those pieces. Great. That's 1 point. We'll call that point P. I need another point. What would be the other point? Any questions how I generated that? Slope is then y sub 2 minus over any questions about how that was generated? Yes. On our calculator in mode is going to contain radians and degrees. I go into y equals. How will I type this in? Before tangent. Good. Then, whoop. Okay. Make sure you're doing your order of operations correctly. Divided by, and then we have to encompass everything in the denominator. X minus pi divided by 4. What is the x value that we are approaching? What do we want to get close to? Pi over 4. Pi over 4, I would like to know what that is as a decimal. 0.785398. So as I go to my table, what value should I plug in? That's close to 0.785, but it is not 0.785. Okay, you guys are doing a really good job of picking values that are close to it. But to appreciate the true understanding of a limit and to get it correct, you must approach it. So don't try to get right on top of it right away, okay? Yes, we'll start at 1, and you need to look for the trend. If a trend does not exist, then the limit won't exist. Mean Girls, right? Limit does not exist. I had never seen Mean Girls before, and finally, all right. So there we have it. What do you want to type in after 1? Get close to it, not right on top of it. Sure, 0.9, then. Sure, 0.8. 0.786. 0.7854. Does it look like it's trending? To what number? 2. So I would agree. I think we could safely say that this limit appears to be 2. Can we now write an equation for the line tangent? Y minus 1 equals 2 times x minus pi over 4. So I have y minus 1 is equal to 2x minus pi over 2. Add the 1, y is equal to 2x minus pi over 2 plus 1. I'll just leave those. I won't even try to combine them. That'll be good enough. Should put that there. My bad. Got a little bit excited. This is my favorite part. I'm going to clear all that. I'm going to type in tangent of x. And I'm going to type in the line tangent, which is 2x minus pi over 2 +1. I'm going to press graph. Remember that the graph of tangent looked like that? Remember that from trig last year? Kind of had that third degree look to it. You see that the line tangent looks like right there at pi/2. Tough to see, isn't it? So I'm going to zoom in as a box because I really want to convince myself that I've done this correctly. So I'm going to zoom in on that portion. That's my graph of tangent. Then this is the line. Isn't that cool? I mean, it just touches once, like just 1 pixel. That's such a complicated problem to be able to say, can you come up with the equation for a line that only touches it once? And you did it. That's sweet. Okay, I have a worksheet for you. I'll hand that out at this point, and you'll be ready to go for Monday.